Hello, guys. Good.
Going to be talking about how we actually use Golang in our respective enterprises. I will be talking about how I use Golang at Freelancer, or how I have used Golang at Freelancer, and Miguel is going to be talking about how he does Golang and how he uses Golang at Brancas. Like I said, a little bit different to what we normally do, so it's not going to be a highly technical talk. It's going to be more a high-level talk, a little bit different than we normally do, but hopefully you guys will enjoy it as well. Before I begin, something happened to my slides. Give me just 1 second. Give me just 1 second. I don't know how I screwed this up. Technical glitch. There's something seriously wrong here. I wanted to start by thanking our sponsors. Obviously, I'm from Freelancer.com, and we're hosting, and not that I want to thank myself, but the company is usually very gracious and very nice to allow us to host meetup like this. We like to give back to the community because we believe that it is it is a good idea for us to share our knowledge and to bring you guys in so you guys can learn a little bit from us and from other communities as well. So we like to do that a lot. I also wanted to thank Brancas. They're our co-organizers in our meetup. They help us quite a bit as well. I'm sure Miguel will talk about their company and what they do. I also wanted to talk about two other sponsors that we have. Singular Live is actually a service that allows us to put live stream graphics in our live stream, which is actually kind of cool. Unfortunately, you're not watching the live stream here, but if you watch our live stream later on YouTube, you'll see the nice, cool graphics that the folks from Singular Live allow us to do, and they were gracious enough to sponsor our organization, which was kind of cool. And also, Slido was also one of our sponsors, and we're actually using Slido for the Q&A. What is going on? Anyway, so like you guys saw earlier in the slide, you guys can actually ask us questions online. If you're a little bit shy, we're going to have a little Q&A session after every speaker. But if you are a little bit shy and just want to actually send us our questions, just log into Slido.com. You actually don't have to log in. Just go to Slido.com. Put GoManila as the event name, and you'll be able to ask questions there. After I finish the talk, I will be able to see the questions here, and we'll be able to answer them for you. And by the way, for those of you on the live stream also, if you guys want to send us questions, also you can ask questions on Slido.com. And every time that I do this, it's kind of weird. Okay, so this is basically a synopsis of what I'm going to be talking about today. Like I said, the main topic is how I use Go in Freelancer, but I wanted to sort of give you guys an idea of the journey of how I ended up actually using Go at Freelancer. So I'm going to talk a little bit about why Go is a good idea to actually use. I'm going to talk about the different use cases for using Go. I'm going to give you a synopsis of the companies that are actually using Go right now in production. Then I'm actually going to talk about the specific use case that led me to use Go for the first time here at Freelancer. And then I'm going to ask about whether you should use Go or not. But anyway, we'll get to that. We'll get to that a little bit later. So why Go? Okay. There are, I did say that this talk was not going to be very technical, but I am going to talk about a couple of the features of Go that actually motivated me to select Go and to like Go. I actually love statically typed languages. I don't know about you guys, but they give me this comfort about not screwing something up that is eventually going to give me some sort of type error in production. And I know that's going to sound a little hypocritical because a few of the folks that know me here happen to know that I'm also a JavaScript developer, and of course JavaScript is a very, very loosely typed language. However, I'm definitely in favor of statically typed languages. And we all know that even the loosely typed languages now are sort of moving in that direction. Python and PHP are doing type hinting now so that they could catch type errors during using static analysis ahead of putting stuff in production. JavaScript isn't doing it exactly, but of course we have TypeScript, which is basically a way to check for types and type issues, also using static analysis during the build time. So even those languages right now are actually moving towards a mechanism to actually check types. So like I said, the fact that Golang is statically typed is definitely one of the reasons why I got motivated to use Golang. The second one was actually the compiler. I'm old. I'm about 45 years old. No, I'm actually exactly 45 years old. And when I started out, most of the languages that I used were all compiled languages. I mean, I use C, and I use Fortran, and I use COBOL, and I use Pascal, and I use Algol, and all those languages that you guys probably heard in computer history class. But the fact that those languages allowed me to create an executable that I can move around and easily execute in different systems was actually something that was very, very, very comforting, without having to copy a slew of dependencies. And not just that, but the fact that the Golang compiler is actually extremely fast. I don't know if you guys have actually used it yet, but it is extremely, extremely fast. And the fact that it includes the runtime in the executable, which makes them a little big, but the fact that it includes the runtime means that we have a single file that we can actually, again, just move from one system to another and execute without having any issues. I love the Golang compiler. Let's wait for the slide. It should come up any moment, apparently. Okay, the tooling. Again, I'm not sure how many of you have been using Golang, but the tooling is fantastic. It has a linter that is great. It does excellent static analysis. And I like the fact that we have a single linter and a single format that we use in Go, as opposed to the slew of possible formats. For example, in JavaScript, you have the wars of who likes what format, whether you're going to use semicolons or not going to use semicolons, whether you're going to indent with 2 spaces or with 4 spaces. With Golang, you don't have to worry about that. So it eliminates all of that from the cognitive load of developing, and you just concentrate on developing. You don't have to worry about format because there's only one way to format things in Go. In addition to the linter, it has mechanisms for documenting your code with GoDoc. It has tools for performance analysis. It has a whole bunch of different tools that actually just come right out of the box. So the fact that they exist is another one of the reasons why I actually like Golang. I talked already about the speed of the compiler, but the speed of the executables is actually something that actually motivated me as well. You guys are going to see when I talk about the example that, again, that in which I used Golang for the first time at Freelancer. This was one of the definitely one of the defining factors of why I decided to use Golang for that particular project. And if it comes, and of course the simplicity. The language is excruciatingly simple. It doesn't have any object-oriented programming. It basically has, around 24, 25 keywords. It is an extremely simple language, and it is intentionally simple. It isn't like in other languages, not that I'm trying to criticize some of these other languages, but some of the languages have like multiple mechanisms to actually do exactly the same thing. In Golang, basically, we have one way to do something, and you don't have to worry about are you going to use a list comprehension, or are you going to use a for loop, or are you going to use, you don't have to worry about thinking about those things because there's only one way to actually do it in Golang. So the simplicity of the language is another one of those reasons that, that I love about Golang. And collectively, all of those reasons, and I'll get to that in a moment, but collectively, all of those reasons also means that the language is relatively easy to learn. And there is the learning curve is relatively low when it goes to Golang. I personally learned probably Golang in a little bit over a week for this project that I'm going to talk to you guys about in a little bit. But I actually have a couple of developers, friends, that I actually taught Golang in a couple of days. I mean, it is so C-like, and it has constructs that are present in other languages. It's just a matter, literally, of learning a few of the new constructs that it has, and that's pretty much it. It is the simplicity of the language is so great that, again, that anybody can actually learn it. So I wanted to mention a couple of the things that we use Golang for, not just here at Freelancer, but in other enterprises. Obviously, I assume that you guys have heard that they use them for microservices. It's actually great for microservices. Not just the speed, but it has a series of libraries that are conducive for the use in microservices. I'm not sure if you guys have heard about gRPC. It's a remote procedure call language that is excellent for utilities like Docker and Kubernetes are actually written in Golang. And as a matter of fact, one of the examples that I'm going to be giving, it has a little bit to do with DevOps, not totally, but you guys are going to understand what I'm talking about. Automation testing, something interesting that I actually did relatively recently was that I did a little experiment with writing a transpiler, so to speak, from robot frameworks to Golang, and I actually wrote it in Golang. Not really sure how many of you are familiar with robot frameworks, but it's a platform to do automated tests in very English plain-like languages. In plain-like language, I'm sorry. It is a little verbose, and it needs to be interpreted before the keywords are actually executed. So it tends to be a little bit slow. And we were trying to figure out what to do about it. And as a proof of concept, what we did was that we transpiled the robot framework keywords into Golang. We actually did a couple because obviously this was just a proof of concept. Then we actually compiled the Go code that was actually calling a Selenium library, and the test actually ran in about 10 to 15% the time that it actually took the original robot framework test to run. So the proof of concept was successful. We haven't continued the project yet, but it was actually a very, very, very interesting project. And for CLI tools, I mean, I don't know if we've actually given a talk about how to do CLI programs in Golang. We should actually give one in one of our future events if we haven't done so already. But this is another, another area where Golang shines. It's actually excruciatingly easy to write a CLI for whatever you want. And as a matter of fact, again, one of the example that I'm going to be talking about later actually has to do with a CLI. So like I promised earlier, I also wanted to talk about who is using Golang in the wild. It'll come back up. There we go. And I know Brancas is using Golang. Obviously, they help us manage this meetup group, and they have a bunch of developers that actually do Golang. I'm not going to talk about what they do because again, Miguel is going to talk about that during the next talk. But obviously, they are in the financial services sector, and they use Golang. Hopefully Google's the next one that's going to come up. Yep, Google obviously uses Golang. They actually use it for a whole bunch of services. They actually have a service called DL.google.com, which is actually used by a whole bunch of other services to actually download. It's like a file service that they use for other services. It's actually pretty cool. We got to fix this. Uber, okay? Uber actually uses it as well. They actually have a series of microservices that they developed in Golang, which is actually kind of cool. And I'm just putting some names here of companies that you guys know and are familiar with. For those of you that are gamers and likes to live stream their games, Twitch actually has a series of services also in Golang. Most of these are actually have to do with their with their live streaming engines, which was actually kind of cool. I gotta fix this. Dailymotion actually also has a series of services Golang that also have to do with their video services. And I actually can't remember the last one I put in here. Oh, SendGrid. I'm actually trying to remember what exactly SendGrid automated, but it had to do something, some DevOps utilities that they actually automated. Also using Golang, but I can't remember off the top of my head which one it was. Let's see who else we got here. Oh, and Medium, you guys obviously know this company. And they as well are actually using Golang in the wild. And if you guys are actually curious a little bit about other companies that might be using it, the Golang Wiki has a list of a whole bunch of companies. There's several hundred companies they actually have listed here that actually use Golang in production. So this would be an interesting list to go and check out. All right. So why did I use Golang? It so happens that I really got to solve this problem. It so happens that here at freelancer.com, I don't know how much you know about our site, but we are actually a two-sided marketplace where we have freelancers on one end and employers at the other end. Freelancers offer their services, whether it's software development or designing or copywriting, a whole slew of services. And then on the other side, we have employers that actually are in need of these services. And what's it called? Of course, they hire freelancers on our platform in order to get work done. What you may or may not already know is that Freelancer, I guess I should have skipped that slide. Freelancer is actually translated in about 28 or 29 different languages. I forgot, to be honest, how many already, but it's a bunch of languages, almost 30 languages. And in order to be able to keep up with translating the entire site, we actually have a cool subsystem that we call the translation system. Hopefully the slide will come up. Here you go. And the translation system works kind of like this. It's actually a 5-step process. For the steps that are automated, one of them is sort of semi-automated, it's kind of manual, and I'll explain how it works. The first part is extraction. It's actually a series of utilities that use static analysis that scour our code for all copies that actually need to be translated. So it looks for all in JavaScript files, in HTML files, in PHP files, in Python files. It just looks for throughout all our code and looks for everything that needs to be translated. Again, we use static analysis, which is kind of cool. And we actually use command line utilities to do this during CI. And anyway, so that's the first step. It's called extraction. After all the copies are extracted, they're actually uploaded into a microservice, which we call the translation service. And during this upload process, two things happen. Not just do the translations get uploaded, but the source text, the copies get uploaded. But we actually check to see if those were copies that existed in the translation system already, in which case we do nothing. If it is a new new copy, we add it to the translation system, and we check for any copies that have been deleted, that don't exist anymore, and we actually delete them from the translation system. So that's the second step. Both of these steps are actually automated. The third step, which is the translation step, we actually have something called a translations panel. Everything that was uploaded actually shows up in this little web interface so that our translators can actually go in there and do their thing and translate it. If you're a Spanish translator, you see it in English and you translate it in Spanish. If you're a Filipino translator, you translate it Filipino. If you're a French translator, you guys get the point. So that's the process that's somewhat manual. Yeah, we do have a web application that actually assists translators in doing this, but it is manual because the translators actually have to manually go there and translate. Then the next two steps are also automated. The download process, basically, depending on at one point in time a module needs certain translations and what language it needs them for, it can actually ask the microservice, hey, I'm such and such domain, I need the translations for this domain in German, and the translation service actually serves the translations for that particular language. And finally, Once the translations are available for the code that's actually going to need them, then we have a series of libraries that facilitate interpolating the translations in place of the original English copies that existed originally. These worked a little bit different depending on whether it's PHP code or whether it's Python code or whether it's JavaScript code. You know, we have different mechanisms to do this. Some of it happened at build time, and we create different builds in different languages. Some of them actually happened at runtime, and they actually pull the translations from the translation system at runtime at that time, and they interpolate it then. But the point is that, again, we have different mechanisms to actually interpolate the translated text to replace the original English text. Okay, one example, and sorry I used JavaScript for example. I know this is a Golang class, but I mean a Golang meetup. But this is an example of a piece of code that has potentially translatable text that our utilities again would use static analysis to try to figure out what needs to be translated. In JavaScript, we actually use a function called t underscore to actually denote any text that actually needs to be translated. We do it a little bit differently in different languages, but this is how we do it in JavaScript. So basically, we have, again, a piece of software that, using static analysis, would just traverse the entire abstract syntax tree and find all the t underscore functions and extract all the text that needs to be translated. Once it does, it actually creates a translations file. We have different formats. This is actually just one of them. It's called the portable object translations file, the POT file. We actually have other formats like xlif and so on and so forth, depending on the language that we're using. But this is actually one of them. So basically, when it extracts them, it actually puts them in a format very similar to this, and it uploads them to the translation system. Once it gets to the translation system, remember I told you guys that there was this web interface that the translators used to actually perform the translation. Well, this is what it looks like. Basically, they will see the text that needs to be translated here. The little part in green actually already has a suggested translation by another translator. But if I believe that translation is wrong, I can actually go in there and type the correct translation and submit it to the translation system. So this is basically a third step. The problem has been that in all of our source code, and I'm only actually talking about one of our web properties, freelancer.com. I'm not talking about our mobile, apps. I'm not talking about the rest of the web properties that we actually manage. We have in the neighborhood of 40,000 copies that we actually have to translate. It started growing so much that when we actually went to check the program that was actually uploading the new translations to the translation system, and then how long it actually took to process that file within the translation system, we noticed that it was actually slowly, incrementally getting slower and slower and slower to the point where it took approximately 30 minutes to actually process between uploading and processing the file. We had to do something because 30 minutes in CI was sort of cost prohibitive. Initially, what we did was we sort of deferred the process and we didn't wait until the translation upload finished so we can continue the CI. But still, it was still cost prohibitive to actually have a process that took 30 minutes, during every cycle. The original process was written in Python, which was great. Actually, Python served us very well for writing this. It was a little nice CLI that would allow us to both upload translations domain and download translations domain. It was actually really cool. But like I said, it was getting progressively slow. And the microservice that we had at the back end is also written in Python. Unfortunately, like I said, it was getting a little bit slow. So what did we decide to do? We actually decided to do two things. Hopefully, yep, we decided to do two things. The first thing was that instead of uploading the entire translations dictionary every time that we extracted, what we did was We saved a copy in CI of the last translation dictionary that we had. We obviously compiled all the new copies, the new translations, or the new English copies, I'm sorry, from all the source code. We did a diff of those those texts ahead of time before we actually upload them, and then we only uploaded the diff. Okay. And the second thing that we did was we moved what we call the CLI from Python to Golang. The first step actually got us down to about 10 minutes, which was actually kind of cool. I mean, going down from 30 minutes to 10 minutes, that's a 60%, 66% savings in time. It was actually incredible. But when we finally moved everything from Golang, we actually got it to process everything from the upload and all the changes to the translation system in the back end. We actually got it under 2 minutes. It was actually a lifesaver to actually find Golang. And remember I told you guys earlier that it actually took me about a week to learn Golang, and I'm sure it'll take you guys probably a couple of days. I'm old, so it takes me a long time of this little process that was causing us so many problems. From 30 minutes to under 2 minutes, it was a great save. We love Golang, and like I said, we're going to start using it for a lot more than this. See what else? Okay, so you guys start using Golang. Have you guys started learning Golang already? Show of hands. Okay, that's cool. So I guess if you're going to look for reasons to use Golang, people like to use languages that are popular, and as you guys seen, the popularity of Golang has been increasing over time. This is from Google Trends, and it is very obvious that since its conception, Golang's popularity has been increasing considerably. And there are actually a series of other indexes that actually show how popular Golang is in comparison to other languages. TOB is one of those. It's very commonly used to gauge how popular these languages are. This one specifically uses Google searches and Bing searches. Actually, it goes across all the search engines and actually averages them out and creates an index on how popular the language are. And you see that it actually is among the top 20 here. The next one is RedMonk. And this one actually, it also tries to gauge popularity, but it does it a little bit different. Sorry, the graph is so small, but it actually uses a number of projects on GitHub versus the number of, the popularity ranking based on hashtags in Stack Overflow. So basically, it's an intersection of both of those things. And you guys see where Go falls there in the graph. But I actually went to check to see, and it actually is ranked number 16 out of all these languages as well in RedMonk. And we also have the IEEE Spectrum. They use a different algorithm to try to figure out what the best languages are. They actually change it from year to year, so I actually don't like to compare the IEEE Spectrum Index from one year to another. But they use factors like ease of use, number of projects that have been using it, the companies that have been using it. So they use a series of other factors, not just searches on Google and number of projects on GitHub. So this is also a good way to gauge to see how popular language is. But language popularity is probably not the only reason why we would want to use Golang. We're all developers and we work for a living. So one thing that is actually very interesting is that in the United States, Golang developers on average get paid more than pretty much developers of every other language, which is actually kind of cool. These statistics are from last year, but and while I don't suggest that it actually necessarily translates to here, it does translate to other regions like Europe and Australia. Golang developers actually do get paid very, very, very well. So that's another good reason. I mean, if the ease of use and the coolness of the language and how easy the language is, isn't motivation enough to actually use the language, maybe getting paid a little bit more maybe could be a good motivation. So these are all the references that that I used to do this presentation, and actually that's all I got for today. Does anybody have any questions?
How can you
Go ahead and talk into the catch box so they can hear you in the live stream. Yeah, that's the microphone.
Hello?
Yeah, catch box.
Hello? 1, 2. Test mic.
Okay, go ahead. Ask. Technical difficulties.
Hello?
Yeah, there you go.
Yeah,
All right.
question number 1, how do you, in clean architecture, how do you make it for the clean architecture?
Well, the thing about clean architecture is that it is applicable to pretty much any language. We have some questions here. Let's start with this one. Okay, it says when Go was first released, didn't have any package management like Maven. How would an enterprise guarantee reputable builds? Well, it so happens that code bases like Docker, breaks Semver. That is true. Because GoMod is relatively new, I believe it came out under a flag on Go 1.11 and finally released officially in 1.12. Yeah, adoption has. I assume this is somebody, hold on a second. is there somebody here who asked for the live stream link? Because obviously it couldn't have been somebody that's watching us on YouTube because they would have the link already. Question is the Python solution using async IO? Yes, actually it was. We actually were using async IO in one of the solutions that was. That's it. All right. Thank you, guys. Marco, where's Marco? There he is.
So he'll be talking about our use case of Go in Brancas. All right, awesome. Good luck. It's already on. I'll turn it off. Yeah, well, I said that. Okay, sure. Okay, well, he's setting up. We'd like again to thank Freelancer.com for again accommodating GoManila. Very, very gracious of you, and we always love using your. Are we? Is there a live stream or? Oh shit! It's not plugged in properly.
I haven't turned it on yet.
Oh, you haven't turned it on. Okay. He hasn't turned it on yet. Okay. So, yeah, always love using your fancy live stream gadgets. All right. While we're still waiting, so Brancas, we build. We're trying to build the API backbone for open banking here in. Good. All right. Thanks.
Okay. Hi, good evening, everybody. So, like Marco said, my name is Miguel Martinez. I'm a systems developer from Brancas, and previous. Half years of professional experience. And before I used Go, I was using Ruby, Ruby on Rails, and also Java, Spring Boot specifically. And I used to be a Go skeptic. If you know me or you're a friend of mine, you'll find the last bullet point surprising because uh, most people know that it's all I talk about nowadays. I'm really in love with Go, but this wasn't always the case. So before I used Go professionally, all my primary experience with Go was memes on Reddit. I mean, that's my only exposure to Go. So this is one of the top posts from the Go subreddit, and the point of the meme is that every third line is if error is not equal to nil, return nil error. And the second, which I think is the top rated post of all time in the Go subreddit, is a meme about generics. But Go is going to have generics soon-ish. So that's going to be addressed. It was in my first job that I had exposure to Go. They wanted to they wanted to introduce a new service, and they wanted to do it in JavaScript. Performance was a consideration, so that's why we didn't want to keep it within Ruby. And I did not want to use JavaScript, so I looked for alternatives. And I was considering Go and Elixir. Like I said, my exposure to Go was memes, negative memes, so I wasn't really looking forward to it. I personally wanted to use Elixir more. It was more interesting to me, especially because I hadn't used functional programming yet. But after a couple of days of thinking about it, I chose to use Go because it was simpler, and I figured it would be easier to pick up. So I wrote a proof of concept in Go, and I really fell in love with it. I decided to look for a job that used it full-time, and that's how I ended up in Bracas. So like Johnny mentioned, one of the primary advantages of Go is its simplicity. There are only 25 keywords or reserved words. So to give a comparison, Java has about 50, and C++ has about 90. I think Rust is somewhere in between the two. There's only one type of loop. There's no do while, there's no while, there's only a for loop. And like Johnny said, there's only usually one way to do things. So there's not a lot of modern language features like generics, not yet anyway, and not a lot of functional features that you'd find in maybe Rust. But the end result is that it's easy to learn and it's easy to onboard people. So a common theme that I noticed in job postings for Go is that they don't require Go experience. They look for more general programming experience, general programming aptitude, because it's very easy for Go to pick up. If you're a good programmer, you won't have any problem picking up Go and becoming productive, and this has definitely been my experience. So I've jumped in a couple of different code bases now. Like I mentioned, Ruby and Java, and the Go code bases were the easiest to get up to speed in by far. So again, also mentioned by Johnny was static typing. There's not a whole lot of research that conclusively shows the benefits of static typing. So there's no hard empirical evidence. If you want to read, Dan Liu wrote a summary of some studies about the topic. But I personally believe that after a certain size, your code base should be in a statically typed language, or else it won't be maintainable. So type errors are caught at compile time instead of runtime. That reduces the amount of unit tests you have to write, so you won't have to check whether the first parameter passed is a string and the second is an integer, because the compiler will do that for you. And static typing allows for more advanced tooling. So like some of the big dynamic languages are introducing type-related features, like Python 3.5 introduced type hints, and Stripe, which is a heavy user of Ruby, wrote Sorbet, which is a static type checker for Ruby. And from what I understand, they'll be working with the Ruby core team to introduce types in Ruby 3. And Microsoft also wrote TypeScript. So the benefits of static typing, I think, are pretty hard to argue against. There's also concurrency. Writing concurrent code in Go feels very natural. So I don't have experience using the threading libraries in Python or Java, so I can't talk about it much in comparison, but I can tell you that it feels very natural, very easy to write concurrent code in Go. So the basic building blocks of which are Go routines. So you can think of them like threads, but they're not always threads. So when you switch between Go routines, you don't have to, it's a lot faster. You can create thousands and thousands of Go routines in your program and not run into any problems. And then there are also channels, which are for passing messages between Go routines. But Go also provides mutexes for more traditional concurrency, for more traditional synchronization. So example, we have 3 URLs in an array. And the for loop in the middle sends fetches all, and then the bit at the end waits for all of them to return. So as you can see, it's quite simple. Quite easy to read, assuming you're familiar with Go syntax. Another is the strong standard library. So there's a very high quality standard library, and it minimizes the need for third-party dependencies. So this is good because it lessens the chance of something like a left pad incident. You have a smaller attack surface. And like I said, it's because of the simplicity of Go, if the documentation for a standard library function doesn't make sense to you, you can jump to the implementation and expect to understand it because it's very clear, very easy to read. And there's also very fast compile time. So the typical Go program will compile in under a second, and startup will be just as fast unless you're making a request, a network request, and waiting on it. So this leads to a very fast feedback loop. You can test your changes very quickly. My experience with a mid-sized Ruby app was that it would take about 5 seconds to start up. For Spring Boot, with hot reloading, it was about 20 seconds, and without hot reloading, it was over a minute. So you're able to test your changes so much quicker. Another thing I didn't mention, like from the standard library includes a production grade HTTP server. So for Django, you need something like Unicorn. For Rails, there's like Passenger, if I remember correctly, or Puma, things like that. But with Go, it comes out of the box. Another advantage is interfaces. So the standard library provides a lot of useful interfaces, like a general reader, writer. They're different from Java interfaces in that they're implicit. So in Java, you explicitly say that your type will implement an interface, but in Go, it's implicit. So say, for example, you depend on, or you use a key value store with a signature get and takes a key the argument and returns a string value. You can declare a KV store interface at the point that you use it, and then your code is very easily testable. So you can write a unit test and either make a mock or a fake for the KV store. You don't need to set up Redis or whatever to test your code. You can leave that for your integration tests. So finally, how Brancos uses Go. Like Johnny mentioned, our entire backend is written with Go. We have a microservices architecture using gRPC. We use Google Kubernetes engine on GCP. Internal communication between our services is done entirely via gRPC. And some endpoints, usually the ones that are exposed to the public, are exposed via REST. This is because it's easier for third parties to integrate with REST. But these endpoints are still implemented with gRPC. We use another library called gRPC Gateway, which adds a reverse proxy that exposes our endpoints as REST. But the implementation is still gRPC. We use a lot of Go tooling. There's a lot of wonderful tooling. So there's a built-in linter from the standard library called GoVet. So it will nag you when your functions are missing comments or when your variables don't follow naming conventions. Like for example, constants aren't supposed to be capitalized in Go. And initialisms like ID are supposed to be fully capitalized. So capital I, capital D. And the linter will warn you about that. There's also GoMock and MockGen, for generating mocks. So some people don't like mocks, but we use a mixture of mocks and fake stubs, all depending on the use case. There's also built-in race detector. So like I mentioned, one of the use cases for Go is concurrent code, and you have to be sure that, or you have to avoid race conditions in your code if you're writing concurrent code. And Go makes this very, very easy with the built-in race detector. You can just pass the -race flag, and it will build a special binary or run your tests with the race detector enabled, and it will tell you if you have unsynchronized access to variables. So here's an example of a data race that's caught by the race detector. This is from the blog post from the Go team about the race detector. And as you can see, it specifies the Go routines, the two Go routines that read and write the same variable without synchronization, without a mutex, or without passing a message with a channel. There's also GoDoc, which in my opinion is the friendliest documentation ever. It's a lot easier to read compared to the Python standard library, in my opinion, or compared to a Java doc. And it's not just for the standard library. Any code published on GitHub, GitLab can be displayed on godoc.org. And within the documentation are runnable or integrated examples. And they also link directly to the implementation. So if you're wondering how a particular method was implemented, or you want to understand how it does what it does, you can navigate to it very quickly. There's also pprof. So one of the use cases for Go is high-performance network services, or just in general, high-performance code. So most of the time, for most cases, you won't have to do anything fancy. But when if you detect that there's a bottleneck, if you find that code is running slower than you expected and you aren't sure why, Go provides ways for you to find out what is causing the slowness. So here, this was generated with the pprof tool. You can see that a big chunk of it is from map usage here in the bottom left corner. We also use a lot of Go tooling from the community. So there's GoFumped, which is written by our own senior systems developer, Dan Marty. It's a It provides no blank lines at the start of a function, and standard library imports should be grouped at the top. And then there's also static check, which has really advanced static analysis. So it can tell when, for example, you subtract a time object from another, and it tells you when you could use time.since instead, which tells you the difference between two time objects. I forgot to mention a while ago, GoFumped is one of the nicest things about Go. So I think Johnny mentioned it earlier. There's an enforced format by the Go tool, and Rob Pike describes it as being not everybody's favorite, but everybody's favorite, because you don't always agree with the rules that it enforces. Like, for example, some people don't like tabs, and it enforces tabs. But it's really nice to have only one way to format code. So in code reviews, that lets you focus on the meat of the code instead of arguing about whether to use tabs or spaces or small things like that. There's also a lot of DevOps applications and tooling that are written in Go, like Docker, Kubernetes, and Drone CI, which is the CI that we use. And it's easier to debug when things go wrong because you already know Go. You can just jump into the source code yourself. So the above tools that I mentioned, like static check or the race detector, Go format, we all enforce those in CI. We also have a tool called Gunk, and this is our front end for protocol buffers. Can I get a show of hands? How many people are familiar with protocol buffers? Okay, 2 people. It's a way of it's tooling around serializing and deserializing data. So it provides like a schema for that clients and servers can use. So there's an upcoming talk this weekend about it at GopherCon Vietnam. Our CTO will be talking about Gunk if you're interested. To give you a brief overview, here's an example of a protobuf schema. So here's a service that defines an echo endpoint with a optional REST endpoint. So if you strip out the option in the middle, it would be a pure gRPC service, so no REST. But as you can see, the option defines a post endpoint. And the gRPC gateway will generate a REST wrapper for that gRPC endpoint. And here's the same endpoint, but written with Gunk. So the key takeaway from Gunk is that the syntax is Go inspired. So there's not a whole lot of people that in this part of the world that have experience with like protobuf, gRPC. So that's one of the difficulties with onboarding people. But because Gunk allows you to define gRPC services in Go syntax, that's one less thing to think about. It's you don't have to keep in mind the protobuf IDL syntax. You just have to remember Go. So this is all valid Go, with the exception of the magic comments. So the plus Gunk magic comment, which is how we define the REST endpoint. We also wrote something called Chrome DP. So this is a way to drive browsers supporting the Chrome DevTools protocol, like Chrome and Chromium. It has the same use cases as Selenium, so it allows us to write our end-to-end tests in Go. So just about everything, barring our front-end code, is written in Go. So it allows us to help out in almost all parts of the system, including the DevOps bits. So we do some interesting things with Kubernetes in our code. We manipulate Kubernetes resources programmatically. And since Kubernetes is written in Go, the Go API is very, very nice, very easy to use. So we get to, it's easy to integrate with Kubernetes from our code base. So here's an example of how Chrome DP can be used. In the first couple of lines, they just instantiate a new Chrome instance. And then towards the end, you can see it navigates to the Go doc for the time package. It waits for the footer element to be visible. That's how it determines that the page is loaded. It clicks on an expand all link. And then it takes the value of the text area. So all very clear, very simple Go. If you're interested, our CTO will also, Ken Shaw, he gave a talk at GopherCon Singapore 2 years ago on Chrome DP. So that's about it for my talk. Does anybody have any questions?
Hello? Yeah. Anyone have any questions? On the web, wala, Charo? There are. Actually, I have a question for you, Miggy.
Yes, Marco, what's up?
No, so coming from different experience, see, like you said, you were like 2.5 years experience working as a developer, right?
Yes.
So in your experience, what things from other languages that you've learned that you picked up helped you learn Go, and also at the same time, what hindered, like became more difficult for you to learn Go because you've picked up these things from other languages?
So when I was teaching myself Go, I think one of the things I struggled with the most was the how to structure your application. There aren't a whole lot of rules in Go, but like with Ruby, there's with Rails in particular, it's very standard. There's only one way to do it. So that's the part I got stuck in the most uh, when I was trying to teach myself Go. As for what helped, I guess the exposure to a statically typed language, it would probably be a little bit more difficult if you had never tried a statically typed language before. But because I had, um, it was pretty easy to pick up Go. Um I guess I'm old because it also took me about a week to really understand Go. Uh, I'd recommend the Go programming languages, the Go programming language book. It's what really helped me understand Go. That's what gave me a deeper understanding of Go. But you can take the Go tour. It's on the main Go site, and it should give you a really nice, really quick overview of Go.
Up there for you to answer.
What's the best practice for logging? So we follow 12-factor logging. We use the Logros package. As for why Logros in particular, I'm not sure. It was decided before my time, but we log the standard out, and then we have we use Stackdriver to collect our logs and view them on GCP. Any more questions?
Should errors bubble up in Go, or should it be handled by the caller?
Well, not sure what you mean by bubble up because
Yeah, in reality, because of the way errors are handling Go, they don't exactly bubble up. They expect to be handled on at the point where the code is detected. In Golang, errors are actually values. They're not exceptions. So if in other languages, and if an exception is not caught, it actually bubbles up to code that actually invoked the code where the error was executed. But in Golang, that isn't how it works. Basically, there's just an error value that's returned, and the value has to be handled at the point where the error occurred. There's no such thing as bubbling up errors.
so. To add to that a bit, people like to rag on Go about how it's verbose because of the error handling, but they say it makes it hard to read, but after a while you get used to it, and I think it encourages very safe programming because you make sure to handle the error. Yes, we do. So if, for example, somebody clones the project and tries to run it locally, it's not gonna fail because the mockgen isn't, the files aren't present on their machine. So I can't recall if you can run godoc.org locally because there's two parts to this question. You can run godoc locally. You won't have all of the features of godoc.org. I can't tell you off the top of my head which they are, but the answer to your question is yes, you can run godoc locally, be as full featured. But definitely you won't be able to access them through the public godoc site. uh, I don't see why it would have to be the same language as the front end, because it's end-to-end testing. We're testing, for example, how the user is filling up the form. So with Chrome DP, we simulate how they fill up the form programmatically. It doesn't really make a difference whether it's being simulated in JavaScript or with Go, but since most of our developers are comfortable in Go, it's easier for them to write the end-to-end tests in Go. Like a regular unit test, basically. So a gRPC method is a method. So you can you can test the logic of the method like you would a normal method. One of the advantages. Not a whole lot. So I'm not against generics. I have not needed them personally, but I see the value that they have for like data structures. Not sure how to answer this question. Oh yeah, I'll skip that. What do I least like about Go? There aren't enough Go programmers in the Philippines, but that's a joke. Honestly, I'm a bit of a fanboy. It's hard for me to think of something I dislike. Hardest to use. Well, I recently tried using it for competitive programming, and since there are no generics, it was kind of hard to use for that. So first, go to do the Go tour. Some people recommend reading Effective Go, which is written by the Go team and talks about how best practices for using Go. But I personally found it kind of confusing rather, to learn best practices and learn the language at the same time. So I would say do the Go tour and then read the Go programming language, because that's what really helped me understand Go. And so same answer for the following question. The Go tour and the Go programming language. I did almost all of the exercises in the book.
Mickey, would you recommend Go as their first programming language, or should they?
Mixed feelings about that. So Go is very opinionated, so I'm not sure it would be the best first language, because then in order to appreciate a lot of what Go gives, you have to come from other languages. So I'm not sure it would be best to learn only one type of loop, for example. But because of the simplicity, I mean, I imagine it would be one of the easier languages to pick up. Okay. Thank you, everybody.
Thanks, man. Good work. Thank you, guys. Yes, that's it for GoManila. Normally, we'd ask you to join us for refreshments, but I guess we already ate all our refreshments and drank all it. But before we leave, again, we'd like to say thank you to Freelancer again for hosting us. And Johnny, do you want to say a few words on behalf of Freelancer?
Yeah, again, thank you very much for coming. like I said, we love hosting these events. We not only do this one with Marco and the guys from Blancas. We do a whole bunch of other events, DevOps events, JavaScript events, Python events. So if you're interested in that kind of stuff, look for those events and join us, please. Thank you for joining us again. Hopefully you learned a little bit today, and hopefully you'll join us again next time. As usual, I have to give the little company pitch. We're hiring. If anybody's interested, see me after the talk. If anybody on the live stream is interested, you can reach me at johnny@freelancer.com. We're hiring mid-level engineers, senior engineers, QAs, Android engineers. We have a whole bunch of positions open. So if you're interested, come. This is a great place to work. Thank you guys, and hopefully I'll see you next time. Oh, and yeah, everybody, can we come to the front so we can actually take a photo?
Thanks, guys. We'll just take a quick photo and then we should be gone.